Hello everyone, my name is Haoyi and this presentation is about Java build tools. So the motivation for this talk is that although Java is well known to be extremely easy to learn, have great performance, and have excellent IDE support, Java build tools like Maven or Gradle don't always live up to that reputation. So many people think of the Java developer experience as being slow and clunky, and that is largely a result of the Java build tools rather than Java itself. So in this presentation, we'll talk about why are Java build tools hard from a user perspective. We'll talk about why they're also hard from an implementer perspective. We look at Mill, which is a build tool, one of my open source projects that tries to improve upon these areas. And one of the interesting ideas behind Mill, which is this idea of object-oriented builds, that really simplifies the build tool user experience. First, why are build tools hard for users? I think it comes down to three areas I mentioned earlier: performance, IDE support, and usability. In terms of performance, people often think that Java is kind of slow and clunky when actually it isn't. But when you look at how it feels developing Java projects on a command line, you can't really blame them. For example, if you take the Netty codebase, which is a popular open source project, it's 500,000 lines of code, takes about 50 seconds to compile in parallel on my laptop. That's a whole project. If you take a single submodule like Netty Common, it takes about 4.5 seconds to compile 29,000 lines of Java code at about 6,000 lines of code a second. So Netty Common is not a terribly large module, and you can imagine anyone who runs Maven compile on Netty Common as they wait 4 to 5 seconds for it to run could understandably assume that Java is kind of slow and clunky to use. But what most people don't realize is that if you take away Maven and just use Java-C directly, it actually takes 1.5 seconds rather than 4.5 seconds. And again, this is compiling the same source files with the same class path using the same version of the Java compiler. We didn't rewrite it in Rust or anything. It's the same Java compiler. But without Maven, it's 3 times faster. And that's using Java-C from the command line where it's cold and doesn't have chance for the JVM running the compiler to warm up. If you let the Java compiler warm up, you'll see that's another 5 times faster. And so now, 5 times faster times 3 times faster, we are now running 15 times faster than Maven to compile the same Java sources using the same class path, using the same Java compiler. And instead of taking 4.5 seconds to compile this module, we now take 0.3 seconds. And so that's why people think Java tooling is slow and clunky, because of this 4.5 second delay to compile a small module. If people took 0.3 seconds to compile the same module, they probably have a very different experience of the Java toolchain and Java developer experience. Next thing we're going to talk about is the IDE support. So every build tool has IDE support because Java is famous for IDEs, so of course they have to have support. But it's often not as good as you'd expect. For example, over here I'm pulled up the Mockito codebase. So Mockito is a popular open source unit testing helper library, and it's built using Gradle. So here's a Gradle build file for one of its submodules, the error-prone submodule. At the first glance, you see it does have IDE support. I can pop up type signatures, I can get syntax highlighting, I do have these inline hints and so on. I can jump to definition. But that's where things end. When I jump to definition, I get JVM args, I get a getter, I get a setter, and I don't get anything else. I can't find usages, I can't see what value was there before I modified it here by appending these values. In general, I don't get the IDE experience that I would hope for, where in most Java code, the IDE can help you navigate around a big complex system and help you figure out what's going on. Here, if I didn't already memorize what JVM args is before, or I didn't have Stack Overflow or ChatGPT to tell me what JVM args does, there is no way I can use my IDE to figure out what it does. It's just totally impossible. I hit a wall. And it's not just JVM args. I try to jump to compiler args. I get nothing. There's nothing here for me to understand what compiler args does. I try to jump to test implementation. There's nothing. Try to jump to compile only. There's nothing. So although in theory, build tools like Maven or Gradle have IDE support, in practice, this IDE support is limited to the point of being useless. I cannot use my IDE to understand what my Gradle build is doing. I cannot use my IDE to debug or investigate what's happening if my Gradle build is going wrong. So I showed you the Gradle Groovy DSL or Groovy syntax, which is what Mockito uses. But the Gradle Kotlin syntax I show in the top right actually has a very similar problem. And even the Maven XML syntax is a similar problem. That if I didn't already know what exec does, I didn't already know what property regex does, there's no way for me to do it without having to go ask Google, Stack Overflow, or ChatGPT. I just have to memorize all these things. And that's why build tools have a reputation for being opaque and hard to work with. Lastly, we'll talk about usability. There are two angles to usability. One is, let's say I have a small project. I have a single file. In this case, it's a small HTML web crawler that scrapes Wikipedia and does a breadth-first search on the Wikipedia article graph. So every article, it looks for the links, and I do a little for loop that does a layer-by-layer breadth-first search over these links to collect all articles within within a set depth of the set start article, which is the first argument you pass to it. So if this didn't have a third-party dependency on JSoup, I could just run it using Java, foo.java from the command line. But because there's one third-party dependency, I now need a build tool. And who here is able to type out the build tool configuration for this using either Maven or Gradle without asking Google, Stack Overflow, or ChatGPT? You cannot, right? Like, it's impossible. You may have been using Maven for 20 years, but I give you a single file with 30 lines of Java. I ask you to build it using Maven or Gradle. You are unable to do it because it's such a pain in the neck. And it's not rocket science. Like, here's a Maven config, but it's just so annoying to have to do this that you probably will end up writing a script in Python. You end up writing a script in Bash. You won't write your script in Java, but not because Java is not a good language for writing this script in, because a build tool set up for getting this Java code to actually run is so annoying that they're not going to do it. And even after you've set up Maven, just having to run the Java code using Maven exec :java -d exec.args equals quote Singapore1 close quote, that itself is a lot more annoying than just saying python foo.py. And all this adds up to, you don't want to use Java for your scripts, not for any fault of the language, but for the fault of the build tools being hard to use. So that's in the small. For larger projects, the problem is not getting started, but for larger projects, the problem is customization. So let's say I have a large project, I need to customize it. As a strawman customization, let's say I want to save the project line count as a line count that TXT resource file to use at runtime. So a bit artificial, but let's roll with it. So you can do this using Maven or Gradle. It's not impossible, but it's surprisingly tricky. I bet none of you would be able to reproduce this plugin configuration yourself without copy-pasting it from Stack Overflow, Google, or ChatGPT. Again, with Maven, it's just so annoying to get started and to customize your build that you end up copy-pasting stuff and cargo culting it without really understanding what's going on. And that's what would end up happening here. But even after you copy-pasted or cargo culted it, that doesn't mean it's actually correct. Like in this case, it came from ChatGPT, and there are multiple bugs in this config that I bet none of you will be able to catch. For example, we forgot to escape our ampersands in the bash snippet, because this is not just bash, it's bash in XML. There's another greater than sign here we need to escape. This doesn't work on Windows because this relies on SH. So there's so many issues here that even though it's such a trivial requirement in the world's most popular Java build tool, it's so easy for it to get wrong. And that's why build tools have a reputation for being extremely error prone. People say, don't customize a build tool if you can get away with not doing so. And this is the reason why, because it's so tricky, so error prone, and so easy to get wrong. So that's why Java build tools are problematic. Like the performance 15x overhead over the Java compiler just makes everything very slow and clunky. IDE support is not great. You can jump to things, the jump to definition tells you nothing, and you end up being just as clueless as if you didn't have an IDE at all. And from a usability perspective, it's so hard to get started with a build tool and so hard to customize a build tool. You end up just copy-pasting, cargo culting things without really understanding it. And this copy-paste ends up being annoying to use and also impossible to maintain. So that's why build tools are hard for users. But why doesn't someone just fix this? I think the reason for that is that build tools are very hard for implementers as well. So every build tool needs to define templated graph computations. You have a small 3-module project you see in the bottom here. Each module has an assembly task, each module has a compile task, and I need a graph because the build tool needs a way to order and parallelize steps, what runs first, what runs later. I need computations because class files and jar files don't create themselves. Someone needs to define how to create them. And they need to be templated because I need some way to avoid duplication where every module looks the same, but they're subtly different. So there are lots of ways to do this. GitHub Actions has YAML with needs keys for the graph, bash snippets for the computations, curly braces for templating. Some build tools try to hide this in the upstream plugins, but that doesn't really solve the problem, because if this is complicated, then that means plugin authors will make mistakes. And I'm sure all of you have encountered cases where plugins are buggy or multiple plugins don't work well together because they screwed up their templated graph computations. And this fundamentally is what makes build tools complex. So that's why build tools are hard for implementers and why we haven't just fixed this overnight. Next, I'm going to talk about Mill, which is one of my open source projects that tries to make progress in these areas. So Mill is an open source build tool that targets Java, Kotlin, and Scala. You can see example build config on the right. It uses these YAML files by default. For example, my root module, build.mil.yaml, extends Java module with these dependencies. I can have a test submodule that extends Java tests with JUnit 4 support with its own dependencies. Hopefully it's a lot easier to read than the Maven config, but not just that, but also easier for you to write and easier for you to reproduce. Like if I want to configure something, I don't need to copy, paste, edit from Stack Overflow. I can just configure it myself. There's a bunch of nice things. It's a smaller project than project like Maven or Gradle, but there are people using it. I know people at Disney and people at Netflix and people at Apple, for example, who are using this in various projects. Not in the whole company, but in small projects within the company. And from the command line, you can run mill, compile, run, test, assembly, all your normal build tool stuff. Apart from the default YAML syntax, mill also has a programmatic syntax. So on the left, I show you the programmatic syntax for mill. It's equivalent to the YAML syntax on the right. It's a bit more verbose, but also allows a bit more customization, which we'll see why that's important in a moment. And mill also lets you write scripts. So for example, HTML scraper we saw earlier, I can just put a build header at the top saying this Java file has this dependency on JSoup, and I can just run /mill HTML scraper.java from the command line, or create an assembly and run it later. Much more convenient than setting up a Maven or Gradle project just to run a small script. So where Mill improves upon the existing build tools is again in the areas of performance, ID support, and usability. In terms of performance, to compare performance, we took the same code base and built it using both Maven and Mill and compared the numbers. So we took the Netty code base we saw earlier, and we ported it to Mill. There's some automation that helps you do the port and take some manual work as well. Got all the tests passing on both, and then we could get the numbers running a bunch of benchmarks. For example, clean compile everything, parallel compile everything, clean compiling a single module, and so on. And what we realized is that just across the board, Mill is a lot more performant than Maven is. And it's not that we do anything special, like we didn't rewrite the Java compiler in Rust or anything. We're using the same Java compiler, same source files, same module layout, same dependencies upstream. We just have a lot less overhead than Maven does. And it's not hard when Maven has 15x overhead over the Java compiler as we saw earlier. Mill is able to be about 4 to 6 times faster than Maven, doing the same thing. So Mill still has overhead over Java C, but significantly less overhead than what than the Maven project does. And we've done similar comparisons with Gradle, and Mill also is significantly faster than Gradle, maybe 3 to 4x rather than 4 to 6x. So again, compiling Java is not the only thing you do day to day in your work, but just shows how much low-hanging fruit there is that Mill is able to become 4 to 6x faster than Maven without having to do any special techniques. Apart from performance, there's ID support angle. I think where Mill is interesting here is where Gradle, the Gradle config you see on the right is configured using these global mutable variables. We are appending to JVM args, and as you know, global mutable variables don't have good ID support. That's why we don't get good ID support here. Mill builds are configured using method definitions using def and overrides. You can see that IntelliJ knows this is an override here. So it's the same information in JVM args in Gradle and fork args in Mill. But where it differs is that IntelliJ knows that fork args is an override. IntelliJ can pull up the documentation for the overridden method if you didn't know what it did. IntelliJ can bring you to the overridden method so you can see the value that you're overriding. In this case, it's an empty sequence of strings. And IntelliJ can help you find usages for the overridden method. So you can see, I'm overriding this method. What does this affect? So you can't do this in Gradle, but you can do this in Mill. So even if you didn't know what fork args did, even if the documentation was out of date or incomplete, even if ChatGPT was hallucinating and not giving you a good answer, you can just navigate around the coding ID to figure out what's going on. Like fork args gets used in runner gets used in run background and run forked, run fork gets used in run. So again, this is what you do day to day, every day in application code. You navigate up and down your call graphs, you navigate from method to method, class to class, override to overridden method. And by that way, even if your code base is not on Google or not in ChatGPT, you're still able to find your way around it and figure out what you need to figure out. And that's what Mill allows you to do in your build without having to rely completely on these external information sources to figure it out. Where in Gradle, you hit the wall and immediately there's nothing you can do except ask for help on Google. In Mill, you can always navigate around, and figure out how things work without being so reliant on these on search engines, LLMs, or even just memorizing everything the build tool does, which is how people traditionally work with Gradle, Maven, and other JVM build tools. So that's the ID support angle, where Mill, I think, gives you much richer and much more useful ID support than traditional build tools like Maven or Gradle. Lastly, I'm going from the usability angle. So we already talked about Mill's ability to write scripts, and that's a lot easier to use than getting started with a small Maven project. I can just add a build header, run mill HTML script.java, and I'm off to the races. If the file gets too big or the build header gets too big, I move it to a separate build.mill.yaml file and let the project grow from there. So it's very convenient to get started using Mill. And as the project grows, often you need to customize things. And where Mill differs is that where most build tools require you to use plugins of some kind or learn a plugin API, Mill, you can just write code to do the thing you want to do. So for example, if I have a simple Java module, like object foo extends Java module with no customizations, this all the default classes, all the default compile step, and so on, I can just write def add a new method line count. That's a task that calls foo.all source files and does some transformation on the output. And that's all I need to do to write a custom task. And if I want to customize my resources, in Mill, everything is a task, resources are tasks, every task is a method, and the way you customize methods is via overrides. So I can do override def resources, I write out my line count txt file with a line count, append it to my resource path, and that's all I need to do to make my line count txt available to running my application at runtime. I think what's interesting here is that there's no Mill line count plugin, there's no Mill exec plugin, there's no Mill resource generation plugin. And in Mill, although there are plugins, you don't need plugins to do every small tweak or customization. You can just write a method that calls another method, processes the output, override methods, and customize it and call super as necessary. And all of these are just standard object-oriented concepts. You know how objects, classes, extends, methods, method calls, and overrides work. And that's all you need to do to customize your Mill build. So that's the usability angle. Both easy to start, also easy to customize later on. So the last area I'm going to focus on a bit is this idea of object-oriented builds. So every build tool needs you to define templated graph computations. And that's what makes build tools complex. If I try to define templated graph class, or you try to define templated graph computation class, it's going to be a complicated class. And what Mill's insight here is that we've all been doing templated graph computations for years or decades at this point. We've just been calling it object-oriented programming. So when I say object foo extends Java module in Mill, I get all the methods from Java module inherited. They call each other and return data to each other. They form a graph. And if I define a new method line count that calls all source files, or I override resources and call super, you already know how this will affect the graph. I don't need to teach you anything. I don't need to teach you how this templated graph API works, because you know override, you know super, you know method calls and method def, you know it extends. All this is already familiar with you. So there's no code here you need to relate it to, like dependency tracking, parallelism, caching, or any of that stuff. All you do is write a very boring object-oriented program, and Mill that defines a build graph, and Mill can handle the rest for you. So that's the idea of object-oriented builds, where I think Mill is very interesting. So many build tools, the complexity comes from this build graph specification in Gradle, in Maven, in Blaze, and others. And in Mill, by allowing you to reuse all the object-oriented knowledge, it allows you to understand the Mill build tool without having to learn a whole new API. All of you already know how Mill works, because all of you already know object-oriented programming. And so if you had to use Mill tomorrow, it would immediately be very familiar to you. So this is the last slide. I think I won't read it out to you, but summarizes everything we talked about. I think the long and short of it is, if any of you have trouble with your build tool, or interested in looking at better build tools, or wondered, is there a better way to do things, I encourage you to try out Mill. So Mill is a newer project. It's certainly less battle tested than the old stalwarts like Maven or Gradle, who you've been using for 20 years. But despite its newness, Mill has a lot of very interesting ideas, and these interesting ideas translate into really concrete improvements to the user experience. Things like being able to just get started easily without having to define a whole new build file. Things like being able to customize a build without having to learn a whole new graph computation API. Things like being able to navigate around your build in your IDE so you never get stuck just because ChatGPT is hallucinating and unable to give you a good answer and the Stack Overflow answers out of date. So all of these are concrete solutions to concrete problems that people face every day in your regular build tools. And I think Mill has been able to take a very solid step forward in attempting to solve these. So the documentation over here at millbuild.org. There's documentation for Java, Scala, and Kotlin, and some Android support and others. There's also documentation on migrating to Mill if you want to migrate an existing project rather than starting a new one. And thank you for listening. I hope you enjoyed it.